Continue with the objective, but before of that, let me introduce myself first. Okay, my name is Muhammad being president and my registration number is AA2047. Okay, the objective of this corporation is to estimate the updated purchase cost of the major equipment. So as we have a HE101 and V201, it use a SEPC, that we call it SEPC, but it means Chemical Engineering Plan Cost Index. Okay, it is to type in this corporation that we use SEPC 582 and SEPC 791. Okay, next is it support the economic evaluation from the process design shown in the PFD, and it engineering all the cost estimate and reflect the current of the market condition and suitable for the further analyze such as CBM, CTM and CGR. Then is a process for the PFD is a schematic illustration of the major equipment that flow past in a chemical or industrial process. Okay, it provides a high level overview of the process that show how the material raw the use into the system and show how they move through the various unit. Okay, that how the product and waste leave. Produce ethanol through the series thermal that ration and separation unit convert from the sugar base into the feedstock. Okay, it's to refine the alcohol product into the fuel or industrial use. I will talk about the expansion about the table of the equipment. Okay, first equipment is a HE101 that from the table it give a heat transfer, stainless steel for the material and the pressure, value of pressure for the tube and shell. Okay, in terms of engineering economy, it was a high material fabrication cost. Okay, then it maintenance is need to follow the requirement and derivative cost related to heating. Okay, then about the V201, it has a diameter for the area, it has a 3 diameter and height 20 meter. Okay, it constructed by the stainless steel SS and it operate the 3.0 bar for the vessel. Okay, in terms of the engineering economy, it have a high capital cost due to its large size and pressure rating and the SS material, and its operating the cost include the raw boiler and the condenser utilities. Okay, that is maintenance of the downtime must be also be considered. Okay, next is estimating purchase equipment cost. Okay, it need to obtain the estimating of the capital cost that chemical plant cost that associated with the major plant equipment. Okay, next we have the main requirement. Okay, the first requirement is a process for the gram, which is PFD. Okay, next is the material and energy, and then the material of the construction, and then size of the capacity for the equipment, such as the equipment attribute. Next for the part 3, I will show you about the formula. Okay, this formula is related and for the effect of time on purchase of the equipment cost. Okay, the formula is C2 equal to C1 and multiply the I2 and divide by I1. Okay, what is C? Okay, C is for the purchase cost and the I is for index. Okay, 1 is based for the time and the cost known, and the 2 is for the current time. For the example, the 1 is for the old cost and the 2 is for the latest cost.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Ba'iyah binti Azhar and my matrix number is AA23029. I will present about the estimated purchase equipment cost CP0. This method used to estimate the initial cost of buying process equipment. The general formula used to find CP0 is log 10 CP0 equal to K1 plus K2 log 10A plus K3 log 10A square. In this equation, CP0 is the estimated cost and K1, K2 and K3 are constants that depend on the type of equipment. The value A represents the size of the equipment such as surface area, volume or power depending on the equipment category. To find CP0, we need to use table A1. On the left side of the slide, table A1 provides a list of various equipment types with their respective constants K1, K2 and K3. For the first example, HE101 refers to a shell and tube heat exchanger with a floating head. The given surface area is 470.25 meters squared. Based on table A1, the value of K1 equal to 4.8306, K2 equal to negative 0.8509, and K3 equal to 0.3187. Substitute these values into the formula, the result is CP0 equal to 68024. For the second example, V201 is a vertical process vessel with a diameter of 3 meters and a height of 20 meters. To determine the value of A, we need to calculate using the formula A equal to pi d square h per 4, which results in 141.37 meters square. Based on table A1, the value of K1 equal to 3.4974, K2 equal to 0.4485, and K3 equal to 0.1074. Substitute these values into the formula. The result is CP null equal to 90878. That's all from me. Thank you.
Hi, Assalamualaikum. My name is Nabi Fasha Binti Arman. My metric number is AA23034. Okay, now I will continue about effect of pressure, which is FP, and effect of material, which is FM. So here we have two formula for FP, which is the first formula, P plus 1 times T divided by 2 times 850 minus 0.6 times P plus 1 plus 0.00315 divided by 0.0063. And the second formula is log Fp equal to C1 plus C2 log P plus C3 times log P squared. Okay, we use for process version. And the second formula, which is log Fp, is for other equipment. And then here, the effect of material of construction for heat exchanger, ratio, and pump, we use this diagram. For example, here we have two example. Okay, the first one example is HE101. Okay, for the table A.2, we can get the C1 is 0.03881, C3 is negative 0.11272, and the C3 is 0.08183. And the pressure range, we get 5.5 bar. So we use the second formula, which is log Fp equals 0.03881 plus negative 0.11272 times log 5.5 plus 0.08183 times log 5.5 squared. And then we get the Fp value is 1.0. Then we find the Fm. So from the table A.3, we get the information that we use tube and shell SS. SS is stand for stainless steel. So the identification number is 5. So we use the value of Fm is 2.7. Okay, next example is for V201 for pressure factor. We get the pressure is 6 bar. Diameter is 3 meter. So we use the first formula, and then we can get the answer, which is 2.47. And then to find the FM, also the same way, we use table A.3. The information we get is virtual SS. So still the same, stainless steel. So the identification number is 20. So we put in the figure A.18. So the FM we get 3.1. So here is the table that I highlight. That's all for me. We move to the next point.
Assalamualaikum. My name is Ainur Nazra Riza binti Jamal, KA24130. So in this part, I'll be explaining about the estimating bare module cost for the non-base case. As you can see in the table, there are two formulas. Number one is for the non-base case CBM, and the other one is for the base case C0BM. The formula for the non-base case is CBM equal to CP0 times with B1 plus B2 and B2 times with FP and FM. And the condition to use it are the number one, the values of FP and FM are greater than 1.0. FP means pressure factor, while FM is the material factor. These two types were already explained in the previous slide. Secondly, it is used when the equipment operates at non-ambient temperature and the material used is not carbon steel. In this example, the type of material we use is stainless steel. Next, for the C0BM formula, it is C0BM equal to CP0 times with B1 plus B2. And the condition for this type is that the equipment operates at ambient temperature. It is also useful to calculate the grassroots cost CGR, which will be explained in the next slide. As you can see in the attached picture, that is table 8.4, which we will use to find the values for B1 and B2 in the formula. So in this example, as you can see, the first equipment is a heat exchanger and the keyword is floating head. We can use this to find the values of B1 and B2 in table 8.4. I already highlighted the value for heat exchanger in yellow and vertical vessel in green. Thus, the value for heat exchanger are B1 equal 1.63 and B2 equal 1.66. While for the vertical vessel, B1 equal to 2.25 and B2 equal to 1.82. Then we can insert this value into the formula for C0BM and CBM for each equipment. The value of CP0, FP and FM for each equipment were already obtained in the previous slide and already explained. So if you don't understand where it comes from, you can watch that part again. Thus, the value for heat exchanger C0BM is 223,798.96 and CBM is 415,762.69. And for the vertical vessel, the C0BM is 369,873.46 and CBM is 1470927.68. Lastly, the final calculation for total module cost CTM and the grassroots cost CGR will be explained in the next video. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Nurfatihah binti Hadi and my metric number is AA23025. Okay, today I want to continue presentation about total module cost CTM and grassroots CGR. So firstly, I want to present about a definition of total module cost CTM. So CTM is cost of making small to moderate expansions or alterations to existing facility. Before you want to find the CTMs, you should know the formula. Okay, the formula CTM is CTM equal to 1.18 times with CBM and the CBM should be multiplied with the index. So CTM is equal 1.18 bracket 415762.69 plus 1470927.68 close the bracket. So the total CTM 2011 is 2226,294.64. And then calculate the index from 2011 to 2025. So the formula is I2 over I1 equal 791 over 582, so equal 1.3591. So the CTM, the total CTM 2011 equal 226,294.64 times 1.3591. So the CTM 2025 is $3025,771.58. So I want to explain about grassroots CGR. Okay, definition of CGR of cost of a new facility in which start the construction on undeveloped land. So before you want to calculate the CGR, you should know the formula. So the formula CGR is CTM plus 0.50 and the CBM should be multiplied with the index. So CGR equal 3025771.58 plus 0.50 bracket 369,873.46 plus 223798.96 close the bracket. So the total of CGR is 3322,607.79 times 1.3591. So the total of CGR is 4515756.25 for 2025. Okay, that's all from me to how to calculate, how to find CTM and how to find the CGR. Okay, next I want to explain about conclusion. Okay, the conclusion is the importance of using the chemical engineering plant cost index, which is a CHEPCH, to adjust the purchase equipment cost over time, ensuring estimates reflect current market conditions. The necessity of process flow diagram (PFD) and detailed equipment specifications, which is size, material, operating conditions for accurate cost estimations. They summarize the influence of pressure, FP, and method of construction is FM on equipment cost, and the methods to quantify these effects. And then the difference between the total model cost CTM for expansion to existing facilities and grassroots CGR cost for new facilities. Lastly, the presentation essentially offers an organized metric for estimating costs in chemical plants, stressing the necessity of purchase data and suitable cost indicators to accomplish trustworthy finance planning and project assessment. That's all for our group. Thanks for watching. Thank you.